Hi, my name is Thiago. I'm an engineering manager on the composition analysis team, and this is part 2 of a video where I talk about the planned improvements to our dependency scanning feature. As mentioned in the previous video, the upcoming improvements to dependency scanning include a new analyzer. This analyzer delivers a comparable experience, and I want to emphasize that we're not removing capabilities, but improving on the user experience. The first change is the configuration of the analyzer. Dependency scanning is adopting CI/CD components which were released as generally available in GitLab 17.0, and they offer many improvements over the use of CI templates. For example, CI/CD components are easier to reuse and offer better versioning capabilities. Builds and monorepos. When running dependency scanning on Python or Java-based projects, such as Maven and SPT, the analyzer attempts to build the project so that it has an opportunity to collect the dependencies used in the build. This is problematic because complex builds may fail, requiring the user to tweak the configuration. Another challenge with this approach is that the build may provide a different solution for the project dependencies, which means that the reported dependencies could be different to the ones in the project's own build. In the new experience, dependency scanning no longer runs builds. This simplifies the setup by taking advantage of the project's existing build and improves our support for monorepos. Monorepos are repositories that host multiple applications, and the new experience offers better compatibility with those types of projects. Finally, the output. Where the previous analyzer would generate a Cyclone SBOM along with the GitLab security report, in the new experience, only the CDX report is generated. This simplifies maintenance of the vulnerability scanning process by delegating this responsibility to the GitLab application. Instead of performing security scans on both in the CI pipeline and in GitLab, the new experience relies on the continuous vulnerability scanning feature of GitLab. Let's have a look at how this works. Continuous vulnerability scanning, or CVS for short, has been generally available since GitLab 17.0. CVS relies on something called Package Metadata Database, or PMDB for short. This database contains information about public packages such as names, versions, license, and more importantly, security advisory information. The security advisory information is also present in the previous dependency scanning analyzer, and it's what it uses to generate a GitLab security report. The new analyzer doesn't have this information because it relies on the PMDB. This makes the analyzer simpler, smaller, and centralizes the security scanning around the same source of information. CVS only works for projects whose dependencies are known to GitLab. When a Cyclone DX SBOM report is declared as a CI artifact, GitLab stores the dependencies present in the report and associates them with the corresponding report. So how does it all work together? The PMDB is kept up to date and available on GitLab infrastructure. GitLab instances that have enabled the feature perform a synchronization of the database at regular intervals. When this synchronization includes new security advisories, an advisory database update event is triggered. At this point, CVS collects a list of component names and versions that are affected by new or updated advisories. CVS then looks up the dependencies registered in all projects to find components that appear in the advisories. When there's a component name and version match, GitLab creates a vulnerability containing the security advisory information. This information can be seen in the vulnerability report. The SBOM update is more or less the opposite of an advisory update. When GitLab records or updates components for a project, this triggers an event that causes CVS to check the existing security advisories for the presence of the associated component name version. If this happens for a change performed on the default branch of the repository, a vulnerability record is created. Otherwise, CVS creates a security finding, which can be seen on the Pipeline Security tab or MR Security widget. Let's look at how the improved dependency scanning feature works with CVS. There are two parts to the process: tasks that happen in the GitLab runner as a CI job, and tasks that happen in GitLab as sidekick background jobs. Starting on the left, we have a project that just received a code change. This triggers a CI pipeline, which runs a build for the project as configured by the user. This build isn't always required. For example, when the project has the required log files committed to the repository. Once the dependency scanning job starts, the analyzer passes all supported artifacts, gathering dependency information. When complete, a cyclone.dxs bomb is generated, which is then uploaded to GitLab. Now, looking at the rightmost part of the slide, we can see that data from multiple sources are consolidated into package metadata DB. The GitLab instance pulls down the PMDB information, which now resides in the GitLab database along with the project dependency information previously uploaded. At this point, CVS kicks in, comparing security advisories with project dependency information. The results are recorded as vulnerabilities or security findings, depending where the code change was made. Finally, these results are made available to users via the GitLab user interface and API. Thanks for watching.